Alright. So today we will be disproving or proving this one. So what this is essentially telling us is that negative 1 is equal to 1. Now what we need to do is to look at the contradiction so that we can disprove this. Okay? Because negative 1 is, well, is not equal to 1 unless we're operating under a different reality. So how do we disprove this? Let's first take it apart and we'll see what happens. So negative 1, what this part is essentially telling us is negative 1 is equal to negative 1 raised to 2 over 2. Now the contradiction here is that, well, first you are squaring the number, next, and then square rooting it. Now there are two properties violated here. You have a negative number within a radical, and that it is not the same because you are squaring it, and the first negative 1 is not being squared here. So what this means is that we all know that 2 over 2 is the same as 1 over 2 times 2, right? In the properties of integer exponents, when you are multiplying the exponents we took apart, it means that you are raising it. You're raising a number that's being raised. For example, 2 squared is a third. This means that you need 3 sets of 2 squared, right? And this is what's telling us. If we take apart negative 1 raised to 2 over 2, we take it apart. What this is telling us is that negative 1 squared, and then you're taking its root. Now, well, first of all, negative 1 squared is not the same as equal to negative 1. It's not equal to negative 1 because negative 1 squared is 1, right? 1 raised to a half is 1, right? So basically negative 1 is not equal to 1. Now, how about this? Let's take apart this guy. Now, this is what we just did here. Okay? We were trying to prove a number to be equal to something by raising it and making it bigger. Well, that's not how it worked. Right? So basically, the contradiction was right front and up negative. So we can say that negative 1 is not equal to 1. This is just within brutal stuff that we know, right? Or influencing context.